welcome to the video tutorial on regression part 3. What we're up to now is we're going to look at an example. We've been looking at sampling variability before and some formulas. Here we're going to see how we can get SPSS to give us the information that would come out of those formulas. So our example is Selena is interested in people's coffee intake and their level of anxiety at 11 a.m. Since most people drink their coffee in the morning, she thinks the participants count the number of coffee that they have per week and has them measure their level of anxiety via a web app at 11 a.m. each day. The anxiety measure is averaged over the week as to try to average out any effects that any specific day might occur, like you might have had a bad trip into work or something like that that made you particularly anxious more than any other day. So try to just average that out a little bit. The data can be found at a link that's listed below in a repository, but just click the link and you should be able to get this data. It's coffee.csv. And what we're going to do is we are going to go over to SPSS and load it in. Okay, let's start loading in this coffee CSV data file. So we're going to go to File, Import Data, CSV Data. Okay, we've done this before, but you should go back to a previous video if you haven't seen it. But here it's just a little bit of repetition, so hopefully you get it. So we're going to click CSV Data. We're interested in coffee.csv. Okay, this is the one I'm going to open, and we'll see what our data looks like once our preview is generated. Everything's correct here, first line, everything, so I'm just going to click OK, and bingo, we have our data. And notice it has coffee here, and it has anxiety, and it says coffee is numeric, but it says it's a nominal scale, even though it's ordinal, really. So this is one of the places where SPSS can sometimes give you the wrong thing. If you wish to change that, we can, but it's not going to affect us at the moment. So the first thing we want to do is get a picture of this thing. So we're going to go up to Graphs, and this type of plot is what's called a scatter plot. So I'm going to come down here to Scatter or Dot, and I'm going to click this, and it's going to bring up another little dialog here that looks like this. We want a simple scatter plot, which is the default. Just simple scatter plot. Let's not go overboard here. It'll be simple and it'll be easy. Click it. Our y-axis is anxiety. Our x-axis is coffee. So this is our setup here. I'm not going to worry about all of this other stuff right now with options and everything. But right now, this is what we're interested in. And we're going to click OK. And it's doing something, and we get a picture. So here's the picture that we get. And you can see that it wasn't that hard to get the picture. So let's go back over to the slide so we can talk about it. Okay, here's the scatter plot we found in SPSS. Same picture, it's just here it's a little bit easier to look at. You can blow it up, make it a little bigger. But this should be the scatter plot you found if you used SPSS and went through the steps. And you can see that we have a strong, positive, linear relationship. Positive means it's going uphill. If we go from left to right, it goes uphill. It's strong in the sense that we can kind of see a linear pattern here. We can actually see the pattern, and the pattern does appear to be a line. Okay, so let's jump back over to SPSS. Okay, so now we're interested in actually getting the regression coefficients. So we're going to come up here to Analyze. And since we're doing regression, the key word you should pay attention to is regression. And you can see there's a whole bunch of different types of regression it will do. We are particularly interested in the linear regression. So the second one down that has a picture. So here I'm going to do linear. Once you click it, a dialog box pops up. Our dependent variable is anxiety. Our independent variable is coffee. And we're just going to go straight, no options or anything right now because we'll learn about more options later. And we're going to say, okay. And it calculates everything for us, gives us several things that we're interested in. But right now we're specifically interested in the coefficients and their p-value associated with it. So this is the piece that I'm going to want to look at and pay attention to. So let's go back over to the slides. Okay, so to make this a little bit easier to see, here's the output we found in SPSS, specifically the coefficients. And we need to know what this means. And we're not going to talk about every little item on here right now, but we're going to get the big pieces off of it. So we're specifically interested in determining what the coefficients are. So we have a coefficient B0, which is 4.926. It's this number here. And B1, which is 0.211 for coffee. So, and notice it says our dependent variable as anxiety. So anxiety is related to the coffee intake. We have on here also the standard errors, which we saw the formulas before last video. And we're not really going to worry about the computation of them right now, but they are here. The t value, which was in our last video as well, if you calculated those out with the data that you have, this would be the information that you get. Right now, we're not going to worry about standardized beta coefficients, but the most important one is going to be this column here in a minute. But first, let's just put our line together. So our line is y hat. It has a hat because it's an estimator. It's not a number, it's a formula. So we got 4.926 plus 0.211x. Okay, this is what we have. So we can interpret this 0.211 for every one additional cup of coffee per week. We expect the average anxiety at 11 a.m. to increase by 0.211. So it's giving us the actual effect, and that's what we were using regression for versus correlation. Correlation will say, yeah, they're related, but it won't tell you how they're related. This tells me exactly how they're related. Have another cup of coffee, you're going to be having a little more anxiety. And how much more? Well, we would expect, on average, that to be about 0.211 units more on the anxiety scale. Okay, so we can also interpret the constant here for a person who drinks no cups of coffee on average. That's our x is equal to 0. We would expect their average anxiety at 11 a.m. to be about 4.926. So this is where you sort of the baseline. These are like the control people, the people that don't drink coffee. Of course, they might drink other things and not telling us, but they don't drink coffee. And this is the sort of background anxiety that exists without the presence of coffee. Okay, so suppose we wish to test a hypothesis that coffee has no effect on anxiety. Okay, how do we set this up? Well, we need to look back at the equation here. So if we have here, if B0 is in the population, then, and this is supposed to be B1 equals 0 in the population, that when we would have Y equals B0 plus B1, but this is 0. So if you notice, we have Y equals B0. In this case, there's no X in this formula anymore, which means X has no effect on Y. Okay? So we can set this up as H naught beta 1, because this belongs to the population, not the sample, and it is a number, so it doesn't have a hat. Okay, so this is equal to 0, or it's not equal to 0. Being equal to 0 means the variable coffee has no effect on anxiety. Let's choose a significance level. I picked 0.021. Why? I don't know. I just don't like 0.05. Okay, so this is going to be our decision rule once we get a p-value. If the p-value is less than alpha, then reject H naught in favor of HA. So here's our output again, and the significance column is the one that has our p-value in it. So we're specifically interested in the one associated with coffee, and here we see that 0.001 is the p-value. So we can come back over and make a decision. Since our p-value is less than 0.001, which is less than our alpha, which is 0.021, we reject H naught. And we can make a conclusion. We have sufficient evidence to claim that the expected 11 a.m. anxiety level is related to the average number of coffee cups of coffee per week, and here's our p-value. And you want to put the p-value on your statements at the end so that others can see how much evidence you have. Okay, that's important here. Always make sure that whenever you make a conclusion, you put the p-value with it so that others can make their own conclusion. All right, so in the next video, we're going to look at confidence intervals, and I will see you there.